Okay, I think we can get started. Good morning, everyone. Welcome to the Department of Toxic Substances Control, or DTSC's webinar on laboratory study of chemicals in nail products. My name is Chen Xiao. I am a public participation specialist with DTSC and will be facilitating this webinar. On behalf of DTSC, we are glad you are participating today. Our distinguished panel members include Carl Palmer, Deputy Director of the Safer Consumer Products Program, Andre Algazi, Branch Manager of the Safer Consumer Products Program, Dr. Ann Cooper-Doherty, Supervisor of the Chemical Evaluation Unit, Christine Papagni, Supervisor of the Product Evaluation Unit, and Tiglat Morad Khan, Environmental Scientist, and today's presenter. There will be one presentation with a question and answer session. Please use the Q&A feature to type in your question. Use the raise hand feature if you wish to ask your question verbally. Instructions will be given later for those of you who are calling in. The webinar presentation slides will be available on the Safer Consumer Products SCP Workshops and Events webpage. This webinar is being recorded and will be posted to the SCP website. Today's agenda includes a presentation on the laboratory study of chemicals in nail products, followed by a Q&A session. The Q&A session will adjourn when there are no additional questions or at 9:50 a.m. Pacific Standard Time, whichever comes first. Please join me now in welcoming Andre Algazi, Branch Manager of the Safer Consumer Products Program, to give the opening remarks. Andre?
Thank you, Chin, and good morning, everybody. And I'd like to echo Chin's welcome. We're glad you're here. And hopefully you're in the right place. We're here to share with you our recently released report on our analysis of nail product samples for a variety of chemicals. This is actually not our first foray into nail products. If you've been following or if you subscribe to our listserv, you may have attended our workshop in the spring at which we discussed our findings of our information call-in for nail product ingredients. Our first work on nail products was analysis of 25 retail and professional nail product samples. We published a report for that in 2012 before our regulatory framework was even finalized. And in that study, we found that some nail products purporting to be free of the quote toxic trio, which is toluene, dibutyl phthalate, and formaldehyde, actually contained one or more of those chemicals, sometimes at high levels. Since then, with the adoption of our regulatory framework, we've been initiated regulatory action on methyl methacrylate and toluene in nail products, and we're currently evaluating triphenyl phosphate. So you may have attended some of our previous workshops. Today, we'll be sharing the results of a larger study of a variety of nail products. This has been a couple of years in the making, so we're excited to share what we've found. And our speaker, Tiglat Morad Khan, has an excellent summary of our work and our findings. So without further ado, I'd like to hand it over to Tiglat to tell you about our nail products lab study report.
Good morning, everyone. Thank you for attending this webinar. My name is Tiglat Morad Khan, and I'm an environmental scientist with the Safer Consumer Products Program. Today, I'll be providing you with a summary of the key findings from our latest laboratory study of chemicals in nail products. A link to our report from the study is being shared in the chat if you would like to use it to follow along with this presentation. Please be on the lookout for additional information which we will be sharing in the chat throughout this presentation. As an overview, I will first briefly discuss our SCP regulatory framework, then provide a brief summary of our nail product efforts to date, and then move on to discuss our laboratory study, where I will summarize our key findings from it. And finally, at the end of this presentation, there will be an opportunity for questions and answers. Our regulatory framework is composed of 4 steps, which are outlined in the figure shown on this slide. The first step is our candidate chemicals list, which contains a list of chemicals that authoritative bodies have determined to have specific hazard traits or exposure potentials. This list is periodically updated. For the most up-to-date list, please visit our CalSafer website. Our candidate chemicals list informs the second step in our framework, which is the priority product stage. Here we evaluate consumer products for exposure concerns. And based on our research, we propose priority products, which are product chemical combinations that have the potential to cause harm. Once a priority product is listed via rulemaking, manufacturers of the priority product conduct an alternatives analysis to see if there are safer alternatives to the chemicals used in their priority product. This is step 3 of our framework. Based on the alternatives analyses manufacturers submit to us, we then issue a regulatory response. This is step 4 of our framework. As part of our regulatory framework, we have been evaluating nail products for over a decade because we are concerned about exposure to harmful chemicals in nail products. Due to these concerns, we have to date undertaken different research projects related to nail products. I would like to acknowledge the fact that DTSC's work related to nail products dates back to 2011, prior to the establishment of SCP, when DTSC collaborated with the San Francisco Department of the Environment, which in 2010 had established a voluntary recognition program for nail salons that seek to use safer nail products. In 2011, DTSC conducted a limited analytical laboratory study with the goals of verifying the accuracy of marketing claims, providing information about the use of chemicals in nail products, and supporting the San Francisco Department's nail salon recognition program. The results of that study were summarized in a report which was publicly released in 2012. Since 2016, SCP has further evaluated nail products by conducting screening research and the recent information column. The purpose of the information column was to request ingredient data from nail product manufacturers to fill in data gaps that we had during our screening research. We have shared our findings at various workshops and webinars, and additionally, we have also proposed several priority products, which are listed here on this slide. For more details on our nail product efforts, please see page 10 of our report. You may also visit our workshops and events page to listen to recordings of our past workshops and webinars on nail products. This laboratory study, which is the purpose of today's webinar, was an effort undertaken as part of our screening research of nail products. The goals of the study were 1. To fill in data gaps and answer questions which we had during our screening research of nail products by measuring chemicals in both retail and professional use nail products. 2. To follow up on DTSC's 2012 nail products laboratory study. And 3. To help us to potentially identify additional priority products. We had several research questions which we wanted to answer with our study. These are summarized on this slide and on the following slide. For a more detailed list of our research questions, please refer to our report. In summary, our research questions were 1. What were the detection frequencies and concentrations of candidate chemicals in different nail products? 2. Do nail product labels accurately identify ingredients? 3. Do nail polishes categorized as professional or retail and by price contain different candidate chemicals or concentrations? 4. What candidate chemicals are detected in products which are marketed to children or marketed as safe for children? And 5. Have retail stores met their public commitments to not sell nail products with certain chemicals? To choose nail products, we used the following criteria. We first wanted to include a wide variety of different product types. We selected various nail products to represent both professional and retail use. Another criterion was purchasing products based on price. Different nail products were also selected to explore various marketing claims, such as non-toxic claims. And we included nail products which are marketed to children or marketed as safe for children. Various nail products were chosen to answer different research questions. Selection of nail products was also based on suggestions from stakeholders and by reviewing ingredient labels for chemicals of interest. We also included nail products which were tested in DTSC's 2012 study. And lastly, nail products were chosen simply based on availability. In total, we purchased 156 nail products, representing 20 different product types as shown in the graph on the slide. More details concerning these products can be found in the appendices of our report. I'm going to pause now for a few seconds to allow you to read this graph. Our environmental chemistry laboratory analyzed these 156 nail products for 52 total target analytes. The analysis was performed using gas chromatography, mass spectrometry, or GCMS. Details regarding quantitation limits, sample preparation, analysis, and list of target analytes can be found in the appendices of our report. As an overview of the results, we quantified 29 different target analytes, of which 24 were candidate chemicals. We also tentatively identified an additional 154 compounds, of which 23 were candidate chemicals. Now I'm going to present our findings for detections of toluene, methyl methacrylate, and formaldehyde. The reason for why we chose to analyze nail products for these three chemicals is that we have prioritized toluene and MMA in nail products as priority products, while in the case of formaldehyde we were under the impression that it was no longer used in nail products except for nail hardeners. Therefore, we wanted to see if formaldehyde had been phased out. First chemical I'm going to present is toluene. Toluene was detected in 27 out of 156 samples, with concentrations ranging from 31 to 187,000 microgram per milliliter. The data presented in the table on the left depicts toluene concentrations greater than 10,000 microgram per milliliter. As you can see from the table on this slide, the highest concentration of toluene was detected in airbrush top coats, with concentrations ranging from 117,000 to 187,000. The table on the right lists product types with the most toluene detects. According to this table, these were top coats, UV gel polishes, and multifunctional products. In this study, we defined multifunctional products as nail products which are intended to function as top coats, base coats and hardeners, or as top coats and base coats. In this case, these multifunctional products function as top coats, base coats, and hardeners. The graph on this slide depicts samples with toluene detections and their concentrations. As you can see, we had samples with toluene detections at high and low concentrations. Samples in the lower end of the concentration range are depicted in the insert shown on the right. Additionally, this graph shows that there were a total of 4 products with marketing claims of non-toxic or toluene-free which had toluene. Methyl methacrylate, or MMA, was detected in 33 out of 156 samples in both non-powdered nil products and in acrylic powders. In non-powdered nil products, the concentration ranged from 26 to 8,760 microgram per milliliter, while in acrylic powders, the concentration ranged from 38 to 450 microgram per gram. The table on this slide depicts MMA concentrations greater than 1,000 microgram per milliliter. As you can see from this table, high concentrations of MMA were detected in various product types, with the highest constant detection in acrylic liquid monomers. Note that the multifunctional product type listed here is a top coat and base coat. The graph on the slide depicts non-powdered samples with MMA detections and their concentrations. Similar to toluene, we had samples with MMA detections at high and low concentrations. Samples in the lower end of the concentration range are depicted in the insert shown on the right. This graph also shows that there were a total of 4 products with marketing claims of non-toxic or MMA-free which had MMA. Finally, formaldehyde was detected in 35 out of 156 samples, in both non-powdered nil products and in acrylic powders. In non-powdered nil products, the concentration ranged from 50 to 15,600 microgram per milliliter, while in acrylic powders, the concentration ranged from 110 to 230 microgram per gram. The table on this slide depicts formaldehyde concentrations greater than 10,000 microgram per milliliter, which was detected in only a nil hardener. The graph on this slide depicts non-powdered samples with formaldehyde detections and their concentrations. Again, we had samples with formaldehyde detections at high and low concentrations. Samples in the lower end of the concentration range are depicted in the insert shown on the right. This graph also shows that there were 7 products with marketing claims of non-toxic or formaldehyde-free which had formaldehyde. In addition to toluene, MMA, and formaldehyde, we also detected other candidate chemical target analytes. The table on this slide lists candidate chemical target analytes where the number of detections is higher or equal to 16. A more detailed list of these candidate chemical target analytes and their number of detections can be found on pages 19 and 20 of our report. For additional details on the detected concentrations and the products they were detected in, please refer to the appendices of our report. As you can see, the most frequently detected candidate chemicals were ethyl acetate, acetone, 1-butanol, and isopropyl alcohol. These typically function as solvents and as a result were detected in many products. This slide lists the volatile, organic, or VOC candidate chemical tentatively identified compounds or TICs by number of detections. For more details on the detected concentrations and the products that were detected in, please refer to the appendices of our report. As you can see, the most frequently detected TIC was heptane, which typically functions as a solvent. This slide lists the semi-volatile organic or SVOC candidate chemical TICs by number of detections. Again, for more information on the detected concentrations and the products that were detected in, please refer to the appendices of our report. As you can see, the most frequently detected TIC was isoferone diisocyanate, which functions as a film former. We also compared our TIC data with ingredient labels to verify ingredient label accuracy. For candidate chemical TICs, we found that out of a total of 23 candidate chemical TICs, 18 of them were detected in nil products that did not list them on ingredient labels. For non-candidate chemical TICs, we found that out of a total of 131 non-candidate chemical TICs, 105 of them were detected in nil products that did not list them on ingredient labels. If you recall, one of the criterion we used to choose nil products was to include nil products which are marketed to children. Out of a total of 156 nil products, 17 of them were marketed for use by children or labeled as safe for children. We detected 15 different candidate chemicals in these products, many of which were nil products with marketing claims of non-toxic and safe for pregnancy. For example, N-methylpyrrolidone or NMP, one of the chemicals which we have prioritized in nail products as a priority product, was detected in 2 nail polishes which are marketed to children. This is concerning as NMP is a developmental and reproductive toxicant. For more details on these products, the different candidate chemicals that were detected in them, and the detected concentration, so please refer to our report. One of our research questions was whether ingredient labels accurately list ingredients. The graph on this slide compares chemical detections and ingredient labels for non-powdered nail products. The concentration data shown in this figure is in microgram per milliliter. The data presented here is for chemicals which were sometimes listed on ingredient labels. Chemicals which were detected in samples and present on ingredient labels or product websites are shown in purple, and chemicals detected in samples but not on ingredient labels or product websites are shown in orange. In general, our analysis revealed that ingredient label accuracy is chemical specific. For example, in the case of the top 3 chemicals, which are ethyl acetate, butyl acetate, and isopropyl alcohol, when these were detected in nil products that listed them on ingredient labels, they were detected at higher concentrations than when they were detected in nil products that did not list them on ingredient labels. The graph on this slide compares chemical detections and ingredient labels for non-powdered nail products. The concentration data shown in this figure is in microgram per milliliter. The chemicals in this graph were detected in samples, but not on ingredient labels or product websites. Some of these chemicals, such as MMA, which is one of the candidate chemicals we have prioritized in nail products as a priority product, was detected at low concentrations. And since these were detected in products which did not list them on ingredient labels, it may be likely that these are present as contaminants and residuals. The graph on this slide compares chemical detections and ingredient labels for acrylic powders. The concentration data provided in this figure is in microgram per gram. None of the detected chemicals in this graph were on ingredient labels or on product websites. For more details on our analysis of ingredient label accuracy, please refer to our report. In conclusion, our analysis of ingredient labels revealed that ingredient labels are sometimes accurate. Another research question which we had was, do nail polishes categorized as professional or retail contain different candidate chemicals or concentrations? In this study, we categorized products as professional or retail. And for this analysis, we only included nail polish lacquers, top coats, hardeners, and multifunctional products, which we classified as solvent-based nail coatings. Solvent-based nail coatings are clear or colored nail coatings that form a hard coating on nails upon the evaporation of their solvents. These products do not need UV light or an LED light to cure. Some examples include nail polishes, lacquers, and enamels. For this analysis, we compared median concentrations and detection frequencies. Chemicals for which the median concentration was 5 times higher in one type of nail coating, professional or retail, than the other were propyl acetate, MMA, N-ethyl 2-pyrrolidone or NEP, and toluene. These chemicals are discussed in more detail in the next few slides. The graph on this slide compares concentrations of propyl acetate between professional samples shown in blue and retail nail coatings shown in green. In general, qualitatively, the trends show that when detected, professional coatings tended to have higher concentrations of propyl acetate. The graph on this slide compares concentrations of MMA between professional and retail nail coatings. Similar to propyl acetate, qualitatively, the general trend shows that when detected, professional coatings tended to have higher concentrations of MMA. The graph on this slide compares concentrations of N-ethyl 2-pyrrolidone or NEP in professional and retail nail coatings. In contrast to propyl acetate and MMA, qualitatively, when detected, retail nail coatings tended to have higher concentrations of NEP. The graph on this slide compares concentrations of toluene in professional and retail nail coatings. Qualitatively, the trend shows that when detected, retail nail coatings tended to have higher concentrations of toluene. The graph on this slide lists some chemicals which were detected at least twice as often in one type of nail coating, professional or retail, than the other. It is important to note that our analysis of detection frequency was done separately from our analysis of median concentrations. Therefore, some of the chemicals in this graph may be different than those I presented in the previous slides. Again, professional samples are shown in blue and retail samples are shown in green. According to this graph, ethylbenzene was detected more frequently in retail samples, while the other chemicals in this graph were detected more frequently in professional samples. In summary, our analysis of median concentration and detection frequency indicated that there are some differences in candidate chemical concentrations and detections. Another research question we had was, do nail polishes categorized by price contain different candidate chemicals or concentrations? In this study, we categorized product by price. If they cost less than $5, we categorize them as low priced. If they cost between $5 and $15, we categorize them as mid-priced. And if they cost more than $15, we categorize them as high-priced. We limited our analysis to solvent-based nail coatings, and we compared median concentrations and detection frequencies. Chemicals for which there was a 5 times difference in the median concentration between low-priced, mid-priced, and high-priced nail coatings were formaldehyde, NEP, toluene, and ortho or O-xylene. These chemicals are discussed in more detail in the next few slides. The graph on this slide compares concentrations of formaldehyde in low-priced, mid-priced, and high-priced nail coatings. Low-priced samples are shown in teal, mid-priced samples are shown in blue, and high-priced samples are shown in orange. Qualitatively, when detected, mid-priced coatings tended to have higher concentrations of formaldehyde. The graph on this slide compares concentrations of NEP in low-priced, mid-priced, and high-priced nail coatings. In contrast to formaldehyde, qualitatively the trend shows that when detected, low-priced nail coatings tended to have higher concentrations of NEP. The graph on this slide compares concentrations of toluene in low-priced, mid-priced, and high-priced nail coatings. Similar to formaldehyde, qualitatively, when detected, mid-priced nail coatings tended to have higher concentrations of toluene. The graph on this slide compares concentrations of O-xylene in low-priced, mid-priced, and high-priced nail coatings. Similar to formaldehyde and toluene, qualitatively, the trend indicates that when detected, mid-priced nail coatings tended to have higher concentrations of O-xylene. The graph on this slide compares detections for some chemicals which were detected at least twice as frequently in any two price categories. Again, our analysis of detection frequency was done separately from our comparison of median concentrations. Low price samples again are shown in teal, Mid-price samples are shown in blue, and high-price samples are shown in orange. As you can see, acetonitrile and ethyl tosilamide were detected more frequently in low-price coatings, while the other chemicals in this graph were detected more frequently in high-priced coatings. In summary, our analysis of median concentrations and detection frequencies indicated that there are some differences in candidate chemical concentrations and detections. One final question we had was whether retail stores have met their public commitments to not sell nail products with certain chemicals. Out of the 12 retail stores from which nail products were purchased, only Amazon, Target, Walmart, and Dollar Tree have clear chemical policies and claims specific to certain chemicals that could be compared to our target analyte detections. And these are formaldehyde, toluene, and dibutyl phthalate. As summarized in our report, the chemical policies of these 4 retailers are varied. For example, while some may encourage manufacturers to formulate nail products without certain chemicals, others may restrict the use of many chemicals. In addition, Amazon's chemical policy applies to its own private labels. It has indicated, however, that it encourages third-party vendors to remove chemicals from their products. Our analysis of the data revealed that in general, Amazon, Target, Walmart, and Dollar Tree met their chemical policies, as the majority of nail products purchased from these 4 stores had low detections of formaldehyde and toluene, and in these cases, formaldehyde and toluene were not listed as ingredients. In summary, we found that marketing claims and ingredient labels continue to be inaccurate. We also found that nail products which are marketed to children or labeled as safe for children contain various candidate chemicals. And lastly, although the data is not very clear, we did find distinct differences in candidate chemical detections and solvent-based nail coatings categorized by price and as professional or retail. We found that professional nail coatings have higher detections of candidate chemicals, while by price, the concentrations of candidate chemicals in nail coatings in the low-priced and mid-priced categories were higher than in the high-priced category. Before I end this presentation, I would like to acknowledge the many different people who have been involved with this project. I would like to thank our Safer Consumer Products team who designed this study, purchased the nail products, and analyzed the data that we received. I also would like to thank our Safer Consumer Products management team who have also been involved in this project, along with staff from OEIM and from the communications office. And I also would like to thank our environmental chemistry laboratory team who did the analysis for us. And this is our contact information. If you have any questions or comments regarding this project, please feel free to contact us. And with this, I would like to thank you again for attending this webinar, and thank you for your attention.
Thank you, Ephraim. Thank you, Tig. We will take this time for a Q&A session. If you would like to ask a question, click the raise hand button and we will call on you. Use the Q&A button at the bottom of your screen to type in your question. Please ask only one question at a time. We will not be using the chat function. If you are calling in, press *9 to raise your hand and press *6 to unmute. Please state your name and affiliation prior to asking a question. So we have a question typed in from an anonymous attendee. Are you planning to release batch codes of products tested?
So I would recommend that that person reach out to us because we would like more clarification on what the question is about. So you can reach out to saferconsumerproducts@dtsc.ca.gov, which is in the chat, or personally reach out to me and I can answer that question.
Thank you, Tig. Another question from another anonymous attendee. How did you confirm that websites selling products are not counterfeit? Were brand owners contacted to verify and/or confirm?
I don't think we did contact brand owners, but I would like someone else from the team, the nail product laboratory team, to answer this question.
Sure, I can answer this question. We did not contact the brand owners. Most of the products were purchased from well-known stores such as Target, Walmart, and Amazon. And so the hope is that the products were the correct products and not counterfeit. Hopefully Target and Walmart are not selling counterfeit products, but we did not verify that.
Thank you, Christine. Our next question comes from another anonymous attendee. Your medium-priced products seem have larger sample size than low-priced products and high-priced products. The conclusion may not be accurate if the sample sizes are very different, especially some sample size is too small.
I can go ahead and take that one as well. And that was an accurate description. We did not purchase what we would consider like a statistically, what's the word I'm looking for? Sorry.
Representative.
Thank you, Andre. We did not purchase necessarily representative samples. We considered these grab samples, and they're not necessarily supposed to be representative of all nail products in the market. We essentially purchased what was available, what we could, and correctly, there were more medium price samples than low and high price.
Thank you, Christine. Our next question, what are the penalties for companies making false marketing claims, especially those products marketed to children? Can we expect for those products to be removed from the market?
I would like someone else from the team to please answer this question.
Will attempt to. I will chime in. As a department in the executive branch of California state government, we don't enforce labeling laws. There are probably some business practice laws that apply to improper labeling of products. So I'm not sure I have the answer, but it's not something we specifically have authority to enforce.
Thank you, Andre. We have a question from Amy Salamone, Washington Department of Ecology. She asks, how did you determine if a nail product was a children's product?
Thank you for the question, Amy. So with the criteria that we used was, for example, if on the label it said that this product is labeled as safe for children, we considered that as a product intended for children, or whether there was a Disney cartoon on the label, we made the conclusion that that's also a product marketed to children.
Or other visuals on the packaging that would be enticing to children. It not necessarily Disney characters per se. It could be any characters that would be give the impression that the product would be marketed to a child.
Thank you, Christine and Tig. So we don't have any more questions in the Q&A tab. If you're on the phone, you can press *9 to raise your hand, and I'll call on you to ask your question verbally. We'll give it a second for more questions to come in. Okay, here's a typed in question. Are you aware of the FTC allows certain ingredient-free claim if the ingredient is used in incidental level within safety limit?
I would like someone from the team to please answer this question. Not aware of this.
Sure. What they're bringing up is the Federal Trade Commission, and it's written more as a statement than a question. We don't enforce anything, any of the rules from the Federal Trade Commission. Maybe you want to expand on your question because I'm unclear what you're asking.
Thank you, Christine. Another question, was the vinyl acetate detected monomer or polymer?
So I will need to check about that. I'm not exactly sure of the answer right now, but we can follow up with you if you would like to know.
And strictly from the data analysis, what was measured by the lab, we wouldn't be able to tell if it was a monomer or polymer. However, we may be able to tell based on the ingredient labels of the products.
Okay. Thank you, Christine. We have a question from Bettina Papadeas. What impacts, if any, do these chemicals have on the illegal disposal of nail products, household hazardous waste into the residential municipal solid waste stream?
Can someone else please answer this question?
Andre, would you be able to answer this one?
Sure. There are likely people disposing of unwanted nail products without necessarily being aware or doing, inquiring very deeply about how they should be disposed of. I don't know that our shining a light on what's in some of these products will have a direct impact on illegal disposal per se, unless, maybe you're wondering if it might prompt people to throw things away. I don't think we could quantify that. And obviously a lot of these solvent-based coatings would have hazardous waste characteristics and should not be placed in solid waste, but should be diverted to, for example, household hazardous waste. So we'll just be speculating. I don't think that our report would have an effect one way or another in a significant way, but that's just an opinion. Sorry, I can't be more specific. Thanks.
Thank you, Andre. So I'm not seeing any more raised hands or questions. So we'll go ahead and go to our closing remarks. I would like to introduce Carl Palmer, Deputy Director of the Safer Consumer Products Program, to give the closing remarks. Carl?
Thanks, Chen. First, thank you everyone for being here for the webinar. We appreciate your attendance. And thanks to Tiglath and our entire team who've worked on this in the Safer Consumer Products Program and the ECL and others. I think just generally, I want to just comment that, this is another effort that we've done over a great number of years. Even before the Safer Consumer Products Program was started, we were engaged in the nail salon sector because of our concerns about exposure primarily to nail salon workers. And we've done a lot of work in that space. So I encourage everyone to read the report. and also to look at the information we got from our information call-in. And I think what it points to for us is the value and importance of getting good information about product ingredients and about the marketplace and the channels. Within our regulatory construct for the Safer Consumer Products Program, we are looking at these sectors as laid out in our Priority Products Work Plan to identify product chemical combinations that we may want to regulate through our framework. And we've already done that with toluene and nail products. We're looking at others in nail products, and we may look at more down the line. But importantly, some of the questions that were raised today we're asking really good questions about, well, what does this mean more broadly in terms of reporting, in terms of compliance, in terms of other laws and regulations? And what I would say to that is that the value of this is just increasing the amount of transparency and information in the marketplace, both for regulators, but also importantly, for manufacturers who want to do the right thing, make their products safer, for consumers who want to get information about what they're buying and any concerns they might have. So this report is important in the context of the collective information that's out there in the sector. There's a multitude of products, and it's a complex supply chain. And so I'm really thankful to the team for putting this out there. I hope that people will read the report, use the information, and feel free to ask follow-up questions of us as you read it, and if you want further clarification. So, Tega highlighted, where the report is, how to contact us with information. Please feel free to do that. And I think that it's really a great opportunity for people to get more information about this important sector, and I assume that will continue on many fronts in the future. And thank you again for attending and your continued engagement. And with that, I'll wrap things up. Thank you.
Okay, so this concludes the presentation. There are 2 questions that were left in the queue after we have finished the Q&A. If you want, please submit those to the Safer Consumer Products webpage, and we will get the answers to you. Thank you all for coming and participating in this great study.